Hello, my name is Dr. Joseph Laron Wilkins. I am an assistant professor at Howard University. I study atmospheric chemistry as it relates to air pollution and air quality along the landscape. So I look at how pollution moves across from satellite resources as well as our ground-based instruments. So this is a form of remote sensing, as well as using chemicals transport models. So this is fancy mathematical equations that predict where pollution and things are going to go, such as the weather is predicted. It seems simple, but it's not. So smoke from wildfires, once it's emitted into the atmosphere, you have to take into consideration what was the source of the burning. So what is the catalyst, so to speak? So how hot was the thing? Was it a plant? Was it a tree? Was it a bush? All these things can determine how high the smoke goes up into the atmosphere. So once these things go up to a certain elevation, it is then hit upon by some winds, for example. So if the winds are going 10 to 15 miles per hour, then it will go typically near the source. If it's hit by a lot stronger winds at a higher altitude, then it'll go a lot further downwind. So generally the same way you would look at a frontal passage or a weather system moving is the same way the air quality moves around. So the way we predict how fires will move around is we use mathematical equations in the form of a chemical transport model or a trajectory model. So this is just fancy terminology for predicting how things are going to do. So you have a starting point and a starting amount of information. So you have the weather, temperature, pressure, humidity, all of these different factors we call the state of the atmosphere. So you have that starting point and you have this thing that you are looking at and the area that you're looking at. And then from that point, you can predict based off the weather conditions, the atmospheric conditions, so such as the wind or the direction of the wind, where things are going to end up and how long they will last in the atmosphere. So this is where our chemistry friends come into play, and they can simply tell us, hey, if you have this particular pollutant in the atmosphere or this chemical in the atmosphere, it'll last this amount of time or lifetime. So you have some that last on the order of hours, some that last on the order of weeks, days, or months. And so typically you can just take that information and you can move it along as you would predicting where the rain is going to be in the next 10 days or 5 days. And you can do the same thing with pollution. This is something that we've been looking at for quite a bit of time. So smoke from fires has been quite a bit of a argument for the past couple of years for many scientists. And so we know that a lot of aerosols or particles of different sizes are emitted from these things. To what degree these things are emitted is the argument point. However, we do know for a fact that about 40% of the harmful air that we're breathing on a typical basis is from these wildfire cases. And so we've seen upwards of 60 to 70% in some cases, and in some cases on a down year, you'll get 10 to 20%. And so we know that we have to study these things more. Many different ways. And so we have it from, we call acute impacts. So these are maybe you're sick for a day of work. Maybe you can't breathe as good as you can. So you have acute like asthma episodes or respiratory issues. And these are just as simple as coughs or lack of being able to breathe fully, all the way up to what we call mortality. And so you can die essentially from negative air quality impacts. And we have everything in between. So you can have respiratory failure, you can have heart disease. These are kind of things from long-term impacts. So we have long-term and short-term and everything in between. So you have to really look at the individual. And we have certain folks that are more susceptible to these things. So if you have asthma, such as myself, you're more susceptible to bad air quality if you're under the age of 5 or over the age of 65. So there's different factors that play, as well as how healthy are your system. The best way to minimize the negative impacts of poor air quality is to, one, stay inside. That's the simplest way. Stay inside and then make sure that your air filter systems for your home or your school or wherever you're going to be inside is up to par. And so the Environmental Protection Agency has a list of these type of filters, and we call them HEPA filters. So they're graded at different ratings, and each rating allows different blockage of different particles that are coming into your home. So that's the first thing you can do, is look at your apps the same way you would as rain or any type of storm. You wouldn't go outside in a hurricane, so don't go outside when it's a bad air quality day. And then from there, the next thing you can do is, if you have to go outside, such as you're an outdoor worker, or if it's an emergency case, or you just need to go to that grocery store for whatever reason, then wear a mask. So these are KN95s, the same as you would during COVID. Protect yourself, whether it's at minimum a cloth mask, which we highly recommend at least a KN95 or better. However, wear a mask, protect yourself, and limit your exposure. And so if you have to be out there, try to limit how much air you're breathing in, which is what you ask. How much air you breathe in is how much you're working outside. So if you're running, if you're jogging, if you're stretching, if you are lifting something heavy, this causes you to take in more air. So you want to limit those type of things that are like we call strenuous activities. And so this is how you can limit your exposures. Forest management decisions are one of the key factors to air quality these days. And so with a little bit of background, I'll add 9 out of 10 fires are started by humans. And so this is a very alarming factor that we have to deal with. And some of these are friendly fires, which is the ones we want. We call them prescribed burns, that are in controlled environments by folks who are knowledgeable of those things. And those fires on the landscape can help mitigate some of the large wildfires that we're seeing these days, such as the ones in Canada, for example. And then you have anything in between, to where you have a rogue campfire or a cigarette butt that just starts a mega fire. And so all of these fires can help contribute to what we're looking at. So the best thing we can do is try to mitigate those. Air quality is not something that only impacts folks that see it, for example. It's something that we generally don't see. And so it's something that is impacting us at mostly any particular given time. So right now, we're speaking about 90% of the United States is covered with smoke. Whether you see that smoke or not is irrelevant. However, you're breathing it. And at any given point in time, there's something on this planet that is on fire. So in a general given year, we're talking about 30 million Americans that are exposed to what we call this wildfire smoke and comorbidities. So you have other factors as well, such as heat and other climate change impacts. And so we have to prepare people for this, because on a given year in the United States, we're talking about 60,000 deaths is a really average year that's related to outdoor pollution, and it can go up to 1 million and 2 globally. And so there's even been years where you've seen 7 to 9 million deaths. And so this is something that, again, isn't going anywhere, and we have to prepare.